In this presentation, I'm going to give an overview of the Estuarine Health Index that is currently being used in South Africa. We'll be touching on why this index, where did it come from, important considerations when one develops indices like that. Then we're going to touch on the process that was followed in South Africa. We'll move into the structure of the health index, important data and information requirements. We'll then look at the calculation of the abiotic and biotic health and how this is combined in the overall health index. And finally, I'll share some uses of this index in South Africa at the moment. So why this Estuarine Health Index? In 1998, the National Water Act was promulgated, and in addition to basic human needs, it also gave a right to water for the protection of aquatic ecosystem functioning. It did it for a series of water resources, of which estuaries was one. So we required a method whereby to determine such ecological water requirements, and important in that method was also to understand the health status or condition of estuaries. So the ecological water requirement methods were developed, and it included an Estuarine Health Index. The first method and index were developed in 1999, and the last update was in 2012. But as we go on, we learn by doing, and that learning will then be incorporated in future updates. So when we look at important considerations for an index of this nature, we'll see that there's been several health indices that were applied in South Africa prior to 1998, which paved the way in terms of our learning to develop the current index. So based on that learning, as well as international learning, there was a few important considerations that had to be taken into account. First of all, it need to assess overall functionality. So the health had to look at both abiotic and biotic, the characteristics, but also the processes. And for that reason, it had to include both abiotic and biotic indicators. And a useful thing of abiotic indicators is that they are often early warning of future change. So you might not see it in the biology as yet, but the abiotic indicator is showing that change is most likely coming. The indicators should also be relatively easy to measure, or there should be suitable proxies that could be used to infer values. And furthermore, it had to be applicable in data poor environments. In South Africa, we often do not have the data to do very data hungry indices. So that was a key requirement for us. So when we look at the development process, we followed a consultative process where national estuarine experts came together in workshops. And at these workshops, we identified a range of potential indicators or parameters that could form part of an index of this nature. And as we identified those, we also provided motivations on how it would work and how it would reflect change in ecosystem health. So eventually we distilled 4 abiotic and 5 biotic indicators, primarily based on the ability for these indicators to inform ecosystem-based functionality. So the one could be used to look at potential changes in the other, and in that way one could look at the overall functionality. These indicators were relatively reliable and stable, and they were relatively easy to measure, or there were suitable proxies that we could use. So the 4 abiotic indicators came to hydrology, hydrodynamics, physical habitat, and water quality. And the 5 biotic indicators were microalgae, macrophytes, inverts, fish, and birds. So in the way these things work together would then give an overall ecosystem health. So if we look at the structure of the health index, you'll see here I've listed the 5 biotic and the 4 abiotic indicators. So the idea is that one describes a natural, or what we also refer to as a reference state, and a present state for each of these. And then one expresses similarity or percentage similarity in the characteristics and functionality of each of these between the present and the reference. So if the present is similar to the reference, then the score comes to 100%. What is also important is that one could not just take one reference survey and compare it with one present survey. One actually has to compare the similarity in a sort of a mean way, where you look at the seasonal functionality and the variability. So it's not just a single survey compared to a single other survey. It had to look at the functionality, the processes, and often you had to understand what happened in the abiotic process to understand some of the changes in the biotic processes. So then the change or the similarity in the abiotics became the abiotic health. The similarities in the biotic were combined into a biotic health, and then together they become the overall ecological health. So to touch on data and information requirements, in essence, what we try to do with this index is to look at the similarity of a present state to a natural state. So the changes in the present state is normally as a result of human pressures like pollution, living resource exploitation, flow modification, or inappropriate land use activities. So the idea is to understand, in terms of the indicators, how did the system function in the natural state, and how has these anthropogenic influences changed its functioning in the present, and how similar is the one to the other. There's various ways in which we could get this kind of information. It can either be through dedicated field surveys. We can look at available literature and information. Where there's not data on the system, one can look at also comparing it with data from similar systems, and one can also use expert judgment to help and understand and to populate the health index in terms of similarity. There is, however, some basic data that is required to really make this index work, and that lies in the hydrology, because if you look at how the ecosystem operates, it's one of the key drivers of the estuarine processes. So in these estuarine health indices, when we apply the estuarine health indices, it's often important that we get simulated natural inflow data. So basically what is done, one looks at rainfall data over a 50 or 70-year period, and based on the characteristics of the catchment, you can then derive or simulate what the inflow to the estuary would have been in each of the months in each of those years. And if you do it for the natural and for the present, it provides a starting point for how at least the hydrology has changed and how that would ripple through the other indicators. And obviously on top of that, one also then needs to look at how some of the other pressures have changed the system from its natural to the present. So if we now go into how do we calculate the health index, you'll see again here the four abiotic indicators, and I'm going to take you through each one of these to show you what are the specific aspects that we look at when we do the abiotic health. So if we look at hydrology, the two things that we look at is the similarities in low flows and the frequency of big floods. And so we score the similarity of each of those, and then the hydrology score gives a weight of 0.6 to low flows and a weight of 0.4 to the floods, and together that then gives you a hydrology similarity score of 56%. If you look at the hydrodynamics, we have four potential aspects that we look at. The abiotic states, or the mouth state, when is the mouth open or closed? we can look at water column stratification, water retention time, and then also water levels in the system. So if you look at the example I gave here, is that we didn't have the information on stratification and retention time, but we could score similarity in abiotic states or melt states and in water levels, and that gave a score. In the case of hydrodynamics, we used the mean score, which gave you a similarity score of 96%. In the physical habitat, we also have 4 aspects that we consider, and you'll see it's the supratidal area, the intertidal area, subtidal, and then the bathymetry and volume, so the size and shape of the estuary. And in this instance, you score the similarity of each, but here the minimum is taken as the similarity score. And then finally, when we look at water quality, we separate water quality into salinity and other water quality parameters. And the reason why we keep salinity separate is that it's not only a water quality parameter, but it can also give you an understanding of the distribution of water types. So if you have a salinity that's very fresh, you know that it's got strong river influence, while if the salinity is close to 35, it's got a very strong seawater influence. So that is why it's dealt separately. When we look at other water quality, we look at nutrients, turbidity, dissolved oxygen, and then also toxic substances. So we give a score, the salinity gets a separate score, each of the water quality parameters get a score, then we take the minimum of the other water quality, and then again we have the weight of 0.4 goes to salinity and 0.6 goes to the other water quality, which gives you a water quality similarity score of 82. So now if you actually want to get to the abiotic health score, each of these indicators carry the same weight. So you basically take the mean of those and then you get your abiotic health score. When we look at the calculation of the biotic health, you'll see the 5 indicators listed here. And in the case of microalgae, we distinguish between phytoplankton and benthic microalgae. And then similar through all the biotic indicators is we look at species richness, abundance, and community composition. So in the case of microalgae, if you give each of these for the phytoplankton and benthic algae a similarity score, in this case, the minimum of any of these scores goes through as the index score for microalgae health. For macrophytes, it's not subdivided and it's looked at as a whole. And again, the species richness, abundance, and composition. You score that and the minimum goes through as the score. The invertebrates, specialists also, or experts also decided to split this because they function very differently into zooplankton, hyperbenthos, and benthos. For these, you give the scores for species, abundance, and composition, and then you take the minimum of any of the similarity scores as the invertebrate score. Similarly, you will do it for fish, so you'll get the minimum of the 3 scores, and again, fish wasn't subdivided, same for birds. So now, in this case, the abiotic indicators also weigh equally, and therefore you basically take the average of these to get the biotic health score. So now to calculate the overall health index score, you'll see I've brought over the similarity scores of the abiotic indicators, and you take the average of that and it becomes the abiotic health score. You look at the biotic indicators, the scores, the average becomes the biotic health score. And then again, weighing equally, these two, the average of these 2 scores, then is the overall health index. So then how do we get that score into what we call the Estuarine Health Index category? So you'll see in the top line, we'll have the percentage ranges, then we have the categories, which you will probably have seen before, the category A to F, and then just some description on what it actually means. So in our case, we had a 64 score, and that means that our estuary that we've looked at here is in Estuarine Health category of C. So finally, when we touch on the uses of this health index, as we saw earlier, it's a basic component of the ecological water requirement studies in South Africa, and also the water classification studies. So it is the method that's used to calculate estuarine health in this stuff under the Water Act. It is also the method that is used to calculate estuarine health in the National Biodiversity Assessment under the Biodiversity Act, and so is it the method when we do estuarine management planning under the Integrated Coastal Management Act. It's used as an index in that as well. And what we are also looking and working on now is estuarine ecosystem accounting, which we're doing with Stats SA, and this health index will also form the basis to depict estuarine health in that instance. So when you want to look at the latest estuarine health indices for South African estuaries, you'll find that in the National Biodiversity Assessment of 2018. If you would like specific details on estuaries, you can check for ecological water requirement or estuarine management plan reports where they're available. They're not available for all estuaries, but if you want to look at specific details, try and find those. And also when you use the results from any report on estuarine health, it is important to quote the date of that report, because the status might have changed, especially in the case of some of the older reports. And finally, this is just a list of useful references that you might want to have a look at that provide some further background or application of this health. Thank you very much, and I hope you find this useful.